Hello friends, let's see another experiment to prepare phenol formaldehyde resin using acid catalyst. You need apparatus, glass rod, 250 ml glass beakers, funnel, measuring cylinder of 25 or 50 ml, watch glass heating mantle. Chemicals that you will be needing are glacial acetic acid, formalin, phenol, crystalline form, concentrated H2SO4 both will do. Theory: Phenol formaldehyde resins are condensation polymers that are obtained by condensing phenol with formaldehyde in the presence of an acidic or alkaline catalyst. Bakelite was the earliest thermosetting resin, named after Belgian-American chemist Bakelite, who patented it in 1909. It was prepared by the condensation of phenol and formaldehyde. Today, there are several types of phenol formaldehyde resins, which are widely used in a variety of applications, such as water-soluble adhesives, laminating adhesives, varnish and lacquer resins, and thermosetting molding powders. So, thermosetting resin, the resin which set upon heating and cannot be reformed once they are set. So, we all know thermosetting resins. Once they are formed by heating, then they cannot be reshaped once they are set in a particular form. The hardening on the heating is due to the formation of extensive crossing between different polymer chains. This leads to the formation of three-dimensional network structure. Example: urea-formaldehyde resin and melamine-formaldehyde resin. Then principle. The principle of the reaction is polycondensation reaction between two or more molecules which proceed step by step with the elimination of small molecules like water, HCl, etc. Depending on the mole ratio of the concentration of the initiator, two types of reaction are possible. To obtain the thermoset, the molecular weight of the polymer must be high. That is, the change length should be high, for which the number of chains should be less. What he is saying is, if you want a thermoset, then the molecular weight of the polymer should be high. That is, the chain length should be high, for which the number of chains should be less. Hence, the quantity of initiator taken initially must be less. To ensure cross-linking, the phenol to formaldehyde mole ratio must be less than 1. Okay. So chain length should be high, for which the number of chains should be less. So thermoset means high molecular weight. हाई मॉलिक्यूलर वेट कैसे होगा जब चेन लेंथ ज्यादा होगी. ओके. और उसमें ज्यादा चेन्स नहीं होगी. Hence the quantity of initiator taken must be less. To ensure cross-linking, phenol to formaldehyde mole ratio must be less than 1. Means formaldehyde तुम्हें ज़्यादा लेना है और phenol कम, तभी less than 1 ratio होगा. To obtain novel-like adhesive, the phenol to formaldehyde mole ratio must be greater than 1, and initial quantity of the initiator should be greater than that of the thermoset. तो अगर novel-like बनाना है तो वो रेशियो फिनॉल और फॉर्मल्डिहाइड का ग्रेटर देन 1 होना चाहिए. मीन्स फॉर्मल्डिहाइड कम होना चाहिए और फिनॉल ज़्यादा होना चाहिए. ठीक है. novel-like किसे कहते हैं हम? जब when there is a linkage formed between phenol and formaldehyde and it is a linear chain, it is novel-like. But when it is cross-linked, then it is bakelite. Okay. So these things you have to remember. So वो कह रहा है bakelite. For the formation of bakelite, the phenol to formaldehyde mole ratio must be less than 1. In presence of an acid catalyst, the phenol is converted to trimethylphenol, which on reaction with simple phenol forms methylene bridge thus leading to a three-dimensional cross-linked structure, which is gummy in appearance. After baking it in an oven at 40 to 45 degree, it gets converted to hard resin insoluble and infusible mass. The first it is gummy, but on heating it becomes hard. Properties: Bakelite has low electrical conductivity and high resistance to heat and chemicals. It has high strength and retains its shape after molding. It is not flexible. Phenolic resins produce products may still slightly under condition to extreme humidity and perpetual dampness. Procedure: Wash all the apparatus thoroughly and dry. See, this is the procedure which is written in the record, but in the actual lab practice, we can use another method also, which will be quite easier than this one given in the record. But just for the sake of literature, I am explaining you this procedure. First of all, you wash all the apparatus and dry it. Mold ratio of the phenol formula, like I told you, it should be less than 1. Means आपने phenol कम लेना है, formaldehyde ज़्यादा लेना है. तभी ratio less than 1 होगा. To ensure formation of mono, di and trimethylol phenol, which are the actual monomers for the reaction. So क्या है हमारे actual monomers for the reaction? Monomethylol phenol, dimethylol phenol, trimethylol phenol. They look like this: monomethylol phenol, dimethylol phenol, trimethylol. Okay, they are the actual monomers of the reaction. Warm the phenol at 60 degree in a heating mantle till it becomes a liquid. At the time of heating, keep the cap of the bottle phenol loose. So फिनॉल को हीट इसलिए करना पड़ता है क्योंकि जब तुम फिनॉल की बॉटल को हाथ लगाओगे तो तुमको पता चलेगा कि वो तो ऐसे क्रिस्टलाइन फॉर्म में है, तो इस फॉर्म में तो चलेगा नहीं, तो हमें लिक्विड फॉर्म में करने के लिए तो थोड़ा हीट करना पड़ेगा और बॉटल लूज रख देना और टेम्परेचर 60 डिग्री चल जाएगा हीट करने के लिए. Weigh the liquid phenol 5.5 gram in a weighing balance. Measure 8 to 9 ml of formalin using measuring cylinder. Measuring cylinder में formalin measure करना और weighing balance पे 5.5 gram phenol. Transfer the 5.5 gram phenol in a 250 ml beaker and add 5 to 6 ml acetic acid because हम acidic catalyst वाला use कर रहे हैं. To this add measured formalin. Now add 7 to 8 drops of HCl. This is a catalyst. Speeds up the reaction. H2SO4 भी डाल सकते हैं. Heat the mixture with constant agitation in a heating mantle at the temperature of 70 degrees. Still the solution turns into a milky white emulsion. आपको एक milky white emulsion मिलेगा. As the milky white emulsion is obtained, take out the beaker and continue the agitation till gummy resin is obtained. तो अब जब आप एजिटेट करोगे तो गमी रेजिन मिल जाएगा. उसको आप एक वॉच ग्लास पे सेपरेट कर लो. Wash it with distilled water 4 to 5 ml to remove the novalac phase if any. तो novalac phase तो रिमूव हो जाएगी क्योंकि वो एडिसिव फेज होती है, वो हमें नहीं चाहिए. हमें चाहिए बेकेलाइट जो कि हार्ड इन्फ्यूजिबल मास होता है. ट्रांसफर द रेजिन इनटू अ वॉच ग्लास एंड ड्राई द प्रोडक्ट इन oven to this temperature 50 to 55 for 2.5 hours till pale pink color is obtained. Pale pink color का प्रोडक्ट आपको फिनोल फॉर्मल्डिहाइड में मिल जाता है. तो एक्सपेरिमेंटल यील्ड यानी जो भी उसका वेट होगा वो होगा. Precaution care should be taken that while heating phenol, the cap of the bottle should be kept slightly loose while heating to avoid blasting condition. Care should be also taken while handling phenol and formalin and acid. Obviously, applications. इसकी applications क्या क्या हैं? If the resin, PF resin are mainly used in the circuit board production, you know, some of the switches in the olden days, black color switches were made of bakelite. It is also used in laminated material like rod tubes and made in great variety form. Okay, then percentage yield आप निकाल सकते हो experimental upon theoretical into 100 से. ठीक है, theoretical yield आप निकाल सकते हो 5.6 plus this into this 9 ml into this. मास निकालना है ना तुमको, तो ये मास बाय वॉल्यूम हो जाएगा. तो मास बाय वॉल्यूम डेंसिटी टू डेंसिटी को वॉल्यूम से मल्टीप्लाई कर दो तो मास मिल जाएगा. मास ऑफ फॉर्मल्डिहाइड, मास ऑफ फिनॉल 5.6. दोनों को ऐड कर लो तो थ्योरेटिकल यील्ड मिल जाएगी, और जो तुमने वे करके निकाला है वो तुम्हारी एक्सपेरिमेंटल यील्ड। तो दोनों का रेशियो ले लो, एक्सपेरिमेंटल यील्ड बाय थ्योरेटिकल यील्ड इनटू 100 कर दो, तुमको मिल जाएगा। और एक बात याद रखना कि नोवालैक इज द लीनियर phenol formaldehyde linkage and the cross-link linkage is bakelite. Okay, now in actual laboratory, how you can prepare this? You know, it is a slightly different procedure, but not completely same, but slightly different. But you will get a clear idea of how the things are going on in the preparation of
I
the
would like to demonstrate how to do backlight practical. So backlight, that is phenol formaldehyde resin. It is a thermosetting plastic. For preparing backlight, the chemicals required are phenol, formaldehyde, glacial acetic acid, concentrated H2SO4 or concentrated HCl. Okay, so now you see how can we prepare backlight. So here acetic acid acts as a solvent. So first we should take 20 ml of acetic acid. Transfer it to 250 ml beaker. Then to that add around 10 ml of phenol. Then to that add around 12 ml of formaldehyde.
2 ml more. The phenol discriminated will
It
be
is 40% formaldehyde solution. Then rinse it, slowly rinse these three components. Then either concentrated HCl or concentrated H2SO4, slowly add to these components or to this mixture from the walls of this beaker.
concentrated H2SO4 is very harmful. Please be very careful while adding.
Then you get phenol formaldehyde resin.
That's how you get the phenol.
See how the backlight is formed.
Okay, friends, I hope you get the idea of phenol formaldehyde using acidic catalyst. The reactions are given to you already. Learn them.